Let's use Paul Vogt's definition of confounding. What he said was a confounder is a variable that obscures or makes it impossible to interpret the relations among other variables. This means that confounders obscure relationships between variables, so we have to adjust them or control for them whenever we do a study. Every confounding variable has three key features. Firstly, a confounding variable has to be associated with the exposure in the population of study. Also, a confounder has to be an independent cause or a predictor for the outcome variable. What I mean by that is the outcome and the confounding variable have to have some kind of relationship. Lastly, a confounder can't be an intermediate step in the causal pathway between the exposure and the outcome. Remember those causal diagrams we discussed a few weeks ago. If the confounder is in a straight line with the exposure and outcome, that's not a confounder. It has to be kind of a triangle shape. We're going to cover that in the next few slides. Here's a decision tree as a tool to step through the process of determining whether a variable can be considered a confounder. Epidemiologists assess potential confounders by evaluating the association between a third variable, the potential confounder, and the health outcome. If no association is found, there is no confounding, and no further evaluations are necessary. But if an association between the potential confounder and the outcome is found, then the next step involves evaluating for an association between the potential confounder and exposure. If an association is observed between the potential confounder and the exposure, then there is confounding. But if there's no association observed, there's no confounding present. Here's an example of one of those confounding triangles I mentioned just a few seconds ago. Let's imagine that someone notices that when sunburns happen, people are also around melted ice cream. And what they want to test is whether melted ice cream is causing the sunburns. So their exposure variable is melting ice cream, and the outcome is the number of sunburns. But this confounding triangle shows that these researchers expected that melting ice cream potentially causes sunburns, but we know that melted ice cream can't cause a sunburn. Something else must be going on that's distorting this relationship between a potential exposure and an outcome. So do you have any ideas on what that could be? Well, if you said hot temperatures, you're right. Hot temperatures have an association with melted ice cream, and hot temperatures have an association with sunburns. So in this case, hot temperatures is the confounder. It has an association with both the exposure and the outcome independently, and so it's distorting the perceived association between the exposure that we wanted to test and the outcome. Before we dive into the next confounding triangle, let's learn about another route of exposure to arsenic, specifically smoking. So studies have found people who smoke are more likely to be at greater risk for developing arsenic-related health outcomes. Why do you think this is the case? So first of all, tobacco and tobacco smoke contains arsenic. And also, smoking makes it harder for the body to eliminate arsenic before it has time to damage cells. Finally, smoking is unhealthy on its own, and it increases risk for outcomes like lung and bladder cancer. Let's look at a potential confounding triangle for arsenic exposure. We already know the exposure is arsenic, and another outcome has been found to be associated with arsenic exposure that we haven't covered yet: bladder cancer. It's important that researchers identify using previous published literature other potential risk factors for bladder cancer. If another risk factor for bladder cancer is also found to have an association with arsenic, then that risk factor should be assessed as a confounder. So how is smoking tobacco a potential confounder? Well, because tobacco can contain arsenic. Smoking has the potential to be a confounder because smoking tobacco and arsenic have a statistical association, and smoking and bladder cancer have a statistical association, so it's included in this confounding triangle. If you were asked to use plain language to describe a confounder, this would be a format that you could use. Smoking may be associated with the exposure arsenic, and smoking may also be associated with the outcome of bladder cancer. Therefore, smoking will be assessed as a potential confounder.